In order to illustrate the choice that the firm has among different combinations of inputs to produce the same quantity of output, we introduce the concept of isoquant. The isoquant associated with the given quantity of output Q gives all the combinations of the inputs that can be used to produce the given quantity of output Q. More precisely, the isoquant associated with the quantity of output Q is equal to the set composed of all the combination of inputs x1, x2, such that the production function f calculated at x1, x2 is equal to Q. For example, with the production function f x1, x2 equal to x1 plus 1 over 4 x2, the isoquant associated to output capital Q equal to 10 is given by all the combination of inputs that produce exactly 10 units of output. We can illustrate the isoquants graphically. First, measure the quantity of input 1 on the horizontal axis and the quantity of input 2 on the vertical axis. Then, graph all the combination of inputs that give exactly 10 units of output. This is the isoquant associated with the level of output of 10.
Oh, wait, I have a question. What do we know in general about the shape of isoquants?
That's an excellent question. In general, it will depend on the production function, so that two production functions can generate different isoquants. However, if we make some assumption on the firm's production function, then we can say something on how the isoquants look like. Before we get into it, I want to introduce the usual convention to give the two inputs the suggestive names of labor and capital. So we will call input 1 labor and input 2 capital. And the production function will be written as capital Q, the output, is equal to the production function, a function of labor L and capital K. Please do not get confused. Even with these names, you should think about the inputs of the production function as input goods, measured with their own unit of measure and that they are used by the firm to produce some output. A very basic assumption on the production function is that the marginal product of any input is always positive. So the marginal product of labor is positive and the marginal product of capital is positive.
Wait, what is the marginal product of labor and capital?
Okay, the marginal product of an input is the partial derivative of the production function with respect to that input. So the marginal product of labor is the partial derivative of the production function with respect to labor. And the marginal product of capital is the partial derivative of the production function with respect to capital. The marginal product of labor measures the change in output produced relative to the increase in labor used, keeping constant the capital. Analogously, the marginal product of capital measures the change in output produced relative to the increase in capital used, keeping constant labor. Now, I would like to go back to your question on the shape of the isoquants. With the assumption of positive marginal product of labor and marginal product of capital, we have that the isoquants must be decreasing functions. However, without other assumptions, we could have that the isoquants are convex functions or concave functions, or functions that are neither convex nor concave. A common assumption of the technology is that the isoquants are in fact convex.
What does this assumption mean?
Well, we can explain it in different ways. But first, let me introduce a very important concept, the marginal rate of technical substitution. The marginal rate of technical substitution of labor for capital is the absolute value of the slope of an isoquant that we can write with this expression. One economic interpretation of the marginal rate of technical substitution is the following. The marginal rate of technical substitution is the amount of capital a firm can give up for 1 unit of labor while still producing the same level of output Q. Now let's go back to the assumption of convex isoquants. The assumption that isoquants are convex means that the marginal rate of technical substitution is decreasing along an isoquant. If you look at the graph, you can see that the marginal rate of technical substitution at A is higher than the marginal rate of technical substitution at B. This means that at B, in order to produce the same amount of output Q, the firm can give up less capital for unit of labor. The intuition for this assumption is that when the firm produces the same amount of output with more labor and less capital, the labor becomes less productive, at least relative to capital.
Wait, so are you saying that if a firm uses the basket of inputs at point A, that labor is more productive than capital, and if it uses the basket of inputs B, that labor is actually less productive than capital?
No, this is not right. I'm not saying which factor is more productive, labor or capital. Maybe the marginal product of capital is higher than the marginal product of labor, both at A and at B. What I'm saying is that the marginal product of labor relative to the marginal product of capital is decreasing along an isoquant. To understand better this assumption, let me state an important fact about the marginal rate of technical substitution. The marginal rate of technical substitution of labor for capital is equal to the marginal product of labor divided by the marginal product of capital.
Okay, wait a minute. Now I'm confused. You said that the marginal rate of technical substitution is the absolute value of the slope of the isoquant.
This is true, and it is also equal to the ratio of the marginal product of labor over the marginal product of capital.
So you're saying that the absolute value of the isoquant is also equal to MPL divided by MPK?
This is right. This is a mathematical result that is very useful in economics. I will postpone the explanation of this and focus on the economic interpretation. Go back to the assumption of convex isoquants. We said that this means a decreasing marginal rate of technical substitution. So at the basket A, the marginal rate of technical substitution is higher than at B. This means that the marginal product of labor divided by the marginal product of capital is higher at A than at B. So the assumption says that the marginal product of labor relative to the marginal product of capital is decreasing along an isoquant. Is it clear now?
Yeah, that's better. But I have a more general question. So why do we always talk about one isoquant? A firm can have more than one isoquant, right?
This is a great question. Of course you are right. For each production function, you have infinitely many isoquants, one for each level of output. However, in this podcast we are focusing on the cost minimization problem of the firm.